Alright, so in Chapter 2, Section 6, we're talking about rational functions. And so it's just a function on top of a function. There's always some places we have to be careful about with these, and it's when the denominators are equal to 0. The book talks about this as being the possibility of having horizontal or vertical asymptotes, and it's as we either approach a value that we're going to have a vertical asymptote, or as x goes to infinity, or as our y value goes to infinity. So these are where we have asymptotes. Let's get a graph of one of these just to see what we're talking about. And we could do this one, 7 minus 3x and 7 plus 8x. So if we're graphing this, so 7 minus 3x and 7 plus 8x. So we see that it looks like we have a vertical asymptote here, and we have a horizontal asymptote here. So there's some place where it just doesn't cross. It doesn't look like it crosses that vertical asymptote. You cannot actually touch a vertical asymptote because it would make our denominator equal to 0, which would be undefined. There are some cases where you can cross a horizontal asymptote. So never say never on that one. But we see a vertical asymptote here. And if I set that denominator equal to 0, I could actually graph it. So x equals negative 7/8. And that green line represents the vertical asymptote. It really should probably be maybe a dotted line instead, since it's not really there. And then I also am going to have a horizontal asymptote on this one. This one would be negative 3/8. And I'll make that one dotted as well. So this is my horizontal asymptote and this is my vertical asymptote. And so the book talks about how to find these values. For a vertical asymptote, set the denominator equal to 0 and find those values where the denominator equals 0. So for the most part, that finds your vertical asymptotes. For your horizontal asymptotes, you have to look at the degree of the polynomials on top and bottom. If the degree is higher on the top, so if n is greater than m, the graph has no horizontal asymptote. If n is less than m, it goes to 0. And if they're equal to each other, the degree of the polynomial on top and bottom are equal to each other, then it's just the coefficients out front. That's how I got this one. I knew it was going to be negative 3/8 because the degree on the top is 1, the degree of the bottom is 1. Notice if I square this, right, I currently don't have that vertical asymptote anymore because I don't have, we're not drawing imaginary vertical asymptotes. But I still have that negative 3/8 because my degrees are the same. If I made this a 5, notice I do not have any horizontal asymptote. I have something that goes up, goes down. There's nothing hugging. I like to think of asymptotes as hugging a line, an imaginary line. So that one doesn't have one. But if I made the bottom larger, then we would see that this thing gets closer and closer to 0. Here would be a case where we actually cross, right? So it crosses, but then it starts hugging that 0. Let's zoom in a little bit so we can see the hugging around y equals 0. I crossed, and then I'm hugging. So this is how we find vertical and horizontal asymptotes. Vertical by setting the denominator equal to 0, and horizontal asymptotes by looking at the degree of the polynomial on top and bottom. Now, there are some times where, this is on page 173, where we can cancel things out. So if you factor the numerator and factor the denominator, hey, an x minus 3 is canceled out. So now it looks like the only vertical asymptote I have is at -1. X equals -1 because that makes the denominator equal 0. But x minus 3 is part of my problem, and so there is a hole there. So notice that there is a hole in the graph at x equals 3 because the function is not defined when x is 3. So that's something to be aware of, that we can have holes in our functions, and we can find those holes in our functions. And then lastly, another type of asymptote are slant asymptotes. So slant asymptotes are when the degree of the numerator is 1 larger than the denominator. So let's go back and look at our graph that we had. Let's make a graph. So I'm going to make a polynomial that is x squared minus 5x plus 1, and in the denominator let's just have 2x plus 5. So let's back this thing up. That's the wrong way. And I can look at this function, right? And the asymptote I have is actually right here. This is a slant asymptote. The way we find that slant asymptote is we just have to divide. This one we would probably use long division. So to see how many times 2x plus 5 goes into x squared minus 5x plus 1. And doing that, I'm just doing it real quick on a scratch piece of paper. I can see that I would get I'd get an equation of y equals 1/2 x minus 15, I think I got 15/4. And so that is my slant asymptote. Again, once you get the linear piece, when you're dividing, like you may get a remainder, just don't use remainder. Just get, once you get the mx plus b, forget about the change. That gives me that slant asymptote. So we have to be able to do synthetic division to find these slant asymptotes. But that happens when the degree of the numerator is 1 larger than the denominator, because when we divide them we're going to get some type of x term.